Hello and welcome back. This video will start section 1.6, which will be on solving various types of equations, not just quadratic equations and linear equations. So the first sorts of equations that we'll look at are just polynomial equations, and these are when you have two polynomials that are set equal to one another. So for instance, here we have, in this example, we have two polynomials. One is x cubed plus x squared, and the other is 4x plus 4. But a polynomial equation is in general form when one side is 0 and the other side is in descending powers. So if we were to put this equation in general form, we want everything on one side of the equation so that one side is just equal to 0. So what I'll have to do is I'll move the 4x and the 4 to the other side by subtracting them. So I'll subtract a 4x and I'll subtract a 4 from both sides of the equation. And the 4x and the minus 4x will cancel. And then the 4 and the minus 4 will also cancel, and we're left with 0 on the right half of the equation. So now this is in general form. So notice that not only is the right half of this 0, but these powers are in descending order. We have the x cubed, x squared, x by itself, and no x, so it decreases. Also, the degree is something that we've looked at before, and the degree of this polynomial equation is going to be equal to 3, and that is just the highest power of x that we see in the equation, or y, or whichever variable we're looking at. The degree will just be the highest one. So let's just practice solving a polynomial equation. So here we have 4x to the fourth is equal to 12x squared. Maybe the first thing that I want to do is put this into general form. So I want everything on one side of the equation, so we'll subtract 12x squared and I'll subtract 12x squared to get 4x to the fourth minus 12x squared. On the right hand side I'll have 12x squared minus 12x squared, and that's just going to be equal to 0. Now notice this can factor pretty well. So first and foremost, I have a 4 and a 12, so I can pull a 4 out of both of these. Also, I have an x to the fourth and an x squared, so I can pull out two factors of x. What I'm left with in the first term, I've pulled out the 4, I've pulled out two factors of x. I'm left with another two factors of x. In this one I have negative 12. When I pull out the 4, I'm left with negative 3. And when I pull out the x squared, there are no x's left. So ultimately I can factor this quite nicely. And now I have two numbers that are being multiplied together. I have this number and this number are being multiplied together to get 0. So I know that one of those two numbers has to be 0. So either 4x squared is equal to 0, or x squared minus, oops, it's meant to be squared, is equal to 0. So let's solve this guy first. 4x squared is equal to 0. I can divide both sides by 4 to see that x squared is going to be equal to 0. And this is kind of silly, but I'll go through the motions. If x squared is equal to 0, x is either equal to the square root of 0, or x is equal to the negative square root of 0. And the square root of 0 is just 0, and negative 0 is 0. So all of this just means x is equal to 0. In this case, in the case when 4x squared is equal to 0. But it could be that x squared minus 3 is equal to 0. In this case, again, because I have that x squared, I'll solve for that by itself. So I'll add 3 to both sides to get, again, x squared, not cubed, is equal to 3. And now I can take the square root of both sides to get x will be equal to plus the square root of 3, or x will be equal to minus the square root of 3. So here we found 3 potential solutions. 1, 2, 3. But in order to check the solutions, I would need to plug them back into my original equation and make sure that everything works. We'll see later that not every solution that we find is in fact a solution. Let's do one more quick example. Here I have an equation. It's not a polynomial equation, but it's not in general form. So let's turn it into general form. So what I need to do is get a 0 on this right-hand side. So if I start writing this right-hand side, I want to get rid of the x, the 8x, and the 12. So I'm going to subtract 8x, and I'm going to subtract 12, so that these guys will cancel. But whatever I do to one side, I have to do to the other. So as I'm writing the right-hand side down, I'll need to subtract 8x and subtract 12. So now, after I simplify this equation on the right-hand side, it's just going to be equal to 0. The way that the book helps us solve this is that we can factor by grouping different terms. So we'll group the first 2 terms, and we'll group the second 2 terms, and we'll factor these. So 2x to the third plus 3x squared. If I'm just factoring this first term, I can see that, oh, I have an x squared term pops out. I have 2 factors of x here and 2 factors of x there. What am I left with? Well, I still have the coefficient of 2, and if I pull 2 factors of x out, I'm still left with 1. And then I have the 3 there, but if I pull the x squareds out, I'm left with nothing more. Here, I can pull out a negative 4 from both terms, and I have 2x plus 3 left. If I pull a negative 4 out, I'm still left with 2. And if I pull a negative 4 out, I'm still left with 3, and all this is equal to 0. And now we can factor some more. 2x plus 3, I've got that as a factor in both of these. So I have x squared minus 4, and on that right-hand side I have 2x plus 3. And now it's the same as kind of the previous question, where I have 2 numbers that I'm multiplying together to get 0. So one of them is going to have to be 0. So x squared minus 4 is equal to 0, or 2x plus 3 is equal to 0. Furthermore, I can solve this by getting x by itself. I will add 4 to both sides, and when I take the square root, I'll have x is equal to the square root of 4, or x is equal to negative square root of 4. And again, I can simplify this, either x is equal to 2 or x is equal to negative 2. On the right-hand side, again, if I'm solving for x, I can subtract 3 from both sides. So 2x will be equal to negative 3. But now I'm multiplying by 2. So ultimately, I'll have x is equal to negative 3 halves. So I have my three potential solutions, 2, negative 2, and negative 3 halves, which I can plug into my original equation to check. At this point, it's a little tedious, so I won't go through all the details, but I'll do this in the next couple of examples. So everything that we've looked at thus far has just been essentially polynomials, but we could have nth roots, something like square roots. And in order to solve these, the general method will be to isolate a radical on one side of the equation, and we'll get rid of it by raising both sides to the nth power. So, for instance, if we have a square root of, say, x, I'm going to get the square root of x by itself, and then I'll square it. And squaring a square root will get rid of the radical sign. At that point, I can solve, unless there are more radicals, in which case I'll just continue squaring, just repeating steps 1 and step 2 until I have no more radicals left, at which point I can then solve, and then I'll have to check the solutions. This is when extraneous solutions pop up that aren't actually solutions. So let's do an example. Let's solve the square root of x plus 3 is equal to x. Note that this plus 3 is not in the square root. This is by itself. So again, to solve, I want to get the square root by itself. So I'm going to subtract 3 from both sides to get, let's see here, I'm just going to erase this for now. X plus 3, the square root of x plus 3 is equal to x minus 3. And now that I have the square root, I'm going to square both sides. So I will square this, and I will square this. Luckily, if we square a square root, this is pretty simple. Over here we'll have a little bit more work to do, but we can FOIL this and expand this. Very quickly, this will be x squared minus 6x plus 9. And now I can start simplifying this and get this into a form that I'm more familiar with. Again, I have an x plus 3 on this side. I'll get all of my terms to the right-hand side. So I want to subtract an x from both sides so that the x's will cancel. And I also want to subtract a 3 from both sides. So what I'm left with is going to be 0 on the left-hand side. Everything will cancel. And then on the right-hand side, I'll have my x squared term. I have a negative 6x minus x. Well, that's negative 7x in total. And I've got 9 minus 3. Well, that's 6. Luckily, the way that this question was written, this is nice and factorable. So this becomes 0 is equal to x minus 6 times x minus 1. How did I know this? Well, when I take the product of negative 6 and negative 1, I get 6. And if I add negative 6 and negative 1, I get negative 7. This is the trick. The product of those guys should be 6, and the sum of those guys should be the term in the middle, which is negative 7. Again, here we can solve this because I have two numbers multiplied together to get 0. One of them will have to be 0. So in this case, x is 6, or x is 1. And this is where it's important to start plugging things back in to check. So if the square root of x plus 3 is equal to x. So let's check. The square root of 6 plus 3 is equal to 6. So let's check and make sure that this is valid. 6 plus 3 is 9, and the square root of 9 is 3. Everything works out. How about on this side? The square root of 1 plus 3 is equal to 1. So 1 plus 3 is 4. The square root of 4 is 2. This is not correct. So this here is not a valid solution, and this is the only solution. When dealing with square roots, these sorts of things will pop up. Check the solutions. Always, always, always check the solution.